things here then are then questions like this, right? It says how many solutions will the following system of equations have? Now, notice that whenever we spoke about solutions, we had like three options, right? Remember, we had it like if we have three graphs. Okay, that's definitely not a graph. And then let's say that we had this line, and then we had that line. Where they intersected was one solution. If we had two lines like this, right? So these are parallel lines. I know they don't look parallel, but they're parallel. This would be zero solutions because they never intersect. And if we had a line that looked like this, they were the same lines, and they would be infinite. It's infinite solutions. But if we don't have a graph, how do we do that? Well, if we go back, okay, I'm gonna go back. We did a lot of stuff. If you go back, see how we have the graphs here, and then we have like a parallel here, and the same lines here. So what I'm gonna write on the new screen is that when you have two lines like this that intersect, if we were to take a look at the equations, okay, that's this equation here and this equation. Notice that our slope is not the same, and our y-intercept, okay, in this case is also just like not the same. So maybe we can just write a little note here saying that one solution, a possibility could be no, well, not no, that makes no sense. Hold on a second. Okay, we can say that they had different slopes, different y-intercepts. Now they don't have to have different y-intercepts, but this is what's generally found, right? If you have no solutions, okay, that means that they don't intersect. Uh, we had said that they have different y-intercepts, so different y-intercepts, but they have the same slope. Okay, that must occur. And then to have infinite solutions, we need to have the same, okay, same line. They're like the same line. So same slope and y-intercept. I'm about to write over my face right now. Okay, perfect. So now from there, oops, okay, that's not that. All right. So from there, uh, let's try to do this. How many solutions will the following system have? Okay, so the way that we can do this, and the way that I would like to do is, instead of just looking at it like this, we're gonna just put them in y equals mx plus b form. So if we have 3x plus y equals 9, all right, you should really pause and try to figure this out on your own. Like totally just try to see if you can get it. Now if you don't get it, fine, hit the play button and see where you messed up, and then pause and keep on going. If you mess up again, play, see where you hit up. So we're gonna move the 3x over. Okay, down comes the y. We cannot combine this, so we write the x first, plus 9, right? Then for the other one, negative y minus 7 equals negative 3x, right? Again, we want to get the y by itself. So wherever the y is, keep them there. Move everything else. So we're going to add 7. Cool. Negative y comes down. Then comes negative 3x and this positive 7 because they cannot combine. They don't both have x's, right? We still can't have this negative 1 there. So we're going to divide everything by a negative 1. And what we're going to have is y equals positive, right? Because negative and negative cancels out, minus 7. And let's compare these two lines, okay? So what I'm going to do is I'm just going to drag them over. And if we compare them, they have the same, oops, I messed this up a little bit here. Oh no, I didn't mess them up. Okay, good. So it looks like they have the same stuff. Let me just make sure everything is right, that I didn't mess anything up, because sometimes I do that. All right, cool. So we have what looks like the same slope, but it's not the same slope. This is a negative, and this is a positive, and different y-intercepts. So different slopes, different y-intercepts, we can assume that this would have one solution if you were to graph it. Now I'm going to attempt to make a sketch. So this would probably be something like, we start at 9, let's just say that 9 was here. You go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1, right? So this would be a line that looks something like this. Okay, I'm drawing this on a writing pad, so it's going to be really bad. And then here, -7 for this one, then up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. So they would probably intersect like here, but they would intersect and have one solution. That's the main thing. All right, so for number 2, same idea, okay? Let's go ahead and just get them into a y-intercept form. Slope-intercept form, sorry, whoa. And then if we were to do that, add 6x to both sides. 4y equals 6x plus 2, because you cannot combine them. Divide both sides by 4. Y equals 6 over 4x plus 2 over 4. And if you kind of remember from like a long time ago, we got to reduce these guys, right? So here you can divide by 2. You can divide by 2. So we get y equals 3 over 2x plus 1/2. That's this first line, right? That's this one. If we solve this one now, we're going to subtract 3x. Negative 2y comes down, right? Please do not forget this negative. Equals negative 3x minus 1. Okay, this negative 3x comes down first. You always write the x first. Divide both sides by -2. And this cancels out. Only these cancel out. The y still comes down. Negative and negative cancel out, become positive. So 3 over 2x. Negative and negative cancel out, becomes a positive, 1/2. When you compare them, okay, how do they differ? Y equals 3 over 2x plus 1/2. Y equals 3 over 2x plus 1/2. They're the same. So if they're the same line, okay, we're talking about a line that literally looks like this, right? If we were to draw this one, and then if I was to draw the second one in the same color, that would look like this. They overlap each other. So this would be infinite solutions. Okay. Great. And then finally, I believe this was the last one. Oh, there's 2 more. Okay. All right. So if we were to do this, actually, you know what? I actually want to do this on a different video, so I'm going to pause this right now.